So you already have some powerful tools to deal with data types when you want something a little bit more generic. I'm going to show you the most powerful tool you have at your disposal in the situation in which you want to use it. So here I have a generics activity, and what this thing does is it basically takes the data in here, which is a list of cat objects and dog objects, and currently what it's set up to do is it takes the cat objects and uses a class to put them on the screen. So here you can see it running. Of course, it's very cute. Well, let's take a look at actually how that list idea works. If we go into our adopt data, and you can see here we have a list of cats. We remember this from the Java Collection API. So what exactly does that do? I mean, sure, yes, we now know that it's a list of those types of objects, but how does that work? Let's go ahead and go into the list class itself and take a look at what its code does. So if you jump in here, you can see right away that we have list E. Okay, well, what does that mean? Well, if you look here, you'll notice that there's an add method, and rather than having a data type, it also has an E. In fact, down here, we see another E. What Java does at compile time is it takes this cat word and it actually, on the fly, replaces this E with that, which means that this here gets replaced with a data type. So what ends up happening at compile time is we basically create a whole new class on the fly. Now let me undo all this because we don't actually want to mess with this code. And take a look at how we can use that for our advantage. So currently I have this cat adapter, and it uses cat t, okay. If I want to use dogs, I could say, oh, all right, well, let me just make another variable called dog, and I could then create variables to set the dog object and be able to then use the dog class. The problem with doing that is that every time I come across another type that I want to use, I'm going to have problems. I have to write new code. Well, what I could do is I could use the interface thing and say, okay, dog is okay, adoptable and animal, okay, and cat is okay, it's also a animal. Okay, well, maybe what I could do is in my adapter I could use our little trick of using interfaces and say, look, I just want an animal, and then use the animal class. Well, let's see how that works. I'll just replace all of these with animal. Okay, as you can see here, now I have a problem. Even though the animal interface is allowing me to specify that, yes, this particular object has signed up to provide all of the animal methods, and they're here, which are 4 different methods, it says nothing about the fact that it's signed up for this adoptable interface. I have 2 different interfaces. Well, okay, this is where generics can really help us. If instead of using interfaces to solve the problem, and I go back to using just cat, I can genericize my class the same way that Java collections do. This is how this works. I'm going to specify in here a letter to represent the type. I'm also going to change this from cat adapter to, let's say, adopt adapter, because I'm going to be making this more generic. And yes, go ahead and change everything that you see there. Great. Okay. So now, every place that I have a cat, I will replace the cat data type with that same symbol that I used up here. So instead of cat t, I'll just say private t. All right. So here's another place where I had cat. I'm going to replace that again with t. And instead of public animal get, I'm going to do public t get, because it'll return whatever this type is. But now I have another problem, right? These particular methods are not available. That's because currently the data type could be anything. So the only methods that I have access to are the methods that go along with a general object. Okay, well, I want to be a little more specific than that. And this is where generics can help us out. There's actually a whole new way of specifying there's actually a whole language to say, I want to accept any type, but also it needs to have these features. And we're going to see our friend extends up here. Now, it's not the same thing as saying, okay, extends a class. This means it extends the functionality. So I can put an interface, or I could put a class here. But if I say T, it has to extend animal. You'll notice that suddenly, sure enough, those methods are now absolutely fine. This would be the same thing as if we had replaced it with animal, but I can now also do this. Using an ampersand, say whatever kind of object that you want to fill this particular adopt adapter with needs to extend animal and adoptable. Those are the limitations I'm setting on what kind of types an adopt adapter can be. So as you can see here now, we have absolutely no red. This is now a generic adapter that can be used for both dogs and cats. So now you can see that if I want to create a new adopt adapter, what I'll need to do is I'll need to actually specify that this is one for cats. And if I wanted to make a dog adapter, let's actually create a new member variable, dog adapter. Then I can just say I want an adopt adapter for the dog type, and basically pass in the same information that I would for this cat adapter. And now this adopt adapter will work for dogs. Using generics is really, really powerful because you can make your code reusable, you can make your code deal with data types that you yourself haven't even created yet, and make your code type safe because, again, all that's going to happen is when this is compiled, the word cat is going to end up replacing everything here that has T.